Hey everyone, welcome back to the channel. I hope you are all having an amazing day. Today we are diving into a powerful tool for fast and efficient database searches, Elasticsearch. We will explore what Elasticsearch is, why it's so effective for search operations, and how to integrate it into your projects. By the end of this tutorial, you'll have a clear understanding of how to harness its capabilities for blazing fast searches in your application. Alright, let's dive into today's topic. Now you might be wondering, what is Elasticsearch? Simply put, Elasticsearch is an incredibly powerful and fast search engine that's designed for full text search and analytics. It allows you to quickly and efficiently search and retrieve data from your database, no matter how large it is. Okay, now let me ask you this. Have you ever built a search feature for your application and found it slow or inefficient? Elasticsearch can solve that problem. It's lightning fast, scalable, and perfect for scenarios where you need to search and filter through massive amounts of data, like product catalogs, logs, or even documents. In this video, I'm going to show you what Elasticsearch is and why it's so powerful, how to set up it and integrate it with .NET Core application, and finally how to use Elasticsearch to implement fast and efficient search functionality on your database. And the best part, I've uploaded the entire project to my GitHub account, so you don't need to start from scratch. Just head over to the link in the description below, download the project and follow along. Also, while you are at it, don't forget to give this video a thumbs up if you found it helpful. It really motivates me to keep creating these tutorials for you, and if you are new here, go ahead and hit that subscribe button and turn on the notifications. Trust me, you don't want to miss what's coming next. Alright, let's get started with Elasticsearch. Elasticsearch was first released in 2010 by Shay Banon. It's built on Apache Lucene, a powerful library for text indexing and search. Elasticsearch was designed to handle real-time distributed search and analytics, making it highly scalable and flexible for various use cases, including log and event data analysis, full-text search, and monitoring. Elasticsearch is a cornerstone of the Elastic Stack, often referred to as the ELK stack. It's widely adopted for its ability to index and search large amounts of data quickly, thanks to its distributed nature and efficient indexing algorithms. Now that you've learned a brief history of Elasticsearch, let's dive into what lies behind full-text indexing in Elasticsearch. Here's an image that illustrates how Elasticsearch works behind the scene to index data. Let me walk you through it step by step. The top left corner represents users who interact with the system. Users might query or upload data to the system. When new data is uploaded, it's first stored in the SQL Server, represented by the database icon. This ensures that the primary data source remains the origin of truth. If it's the first time a query is made using the search client, the system fetches data from the SQL database. The data is then indexed in Elasticsearch, making future searches faster. This indexing process involves converting structured data into a searchable format optimized for full-text search. Elasticsearch acts as a secondary database specifically for search queries. It provides efficient near real-time search results by working with indexed data. After data is indexed, all subsequent search requests are handled directly by Elasticsearch. The search client interacts with Elasticsearch to retrieve data quickly without querying the SQL Server again. Elasticsearch supports full-text search by breaking down large pieces of text into searchable tokens. Alright, now that you understand how Elasticsearch works, let's dive into a real-world scenario to implement all these features. Okay, now that we've covered some basics of Elasticsearch, let's move on to the next part of our tutorial, installing Elasticsearch on your PC. First things first, Elasticsearch has an official website where you can find all the resources you need. You can visit elastic.co and navigate to the download section to get the latest version of Elasticsearch. They provide options for various platforms, so you can download the one that suits your system. But here's the cool part. You can also set up Elasticsearch as a Docker container. If you are already using Docker, this method is super convenient and fast. I've included the link to the official Elasticsearch Docker image in the description below for you. Now I've got Docker installed on my machine, so I prefer using Docker to install Elasticsearch on my machine. It's fast killing and avoids any installation clutter on your system. All you need is the official Elasticsearch Docker image, which you can easily pull and run. Once you have Docker set up on your machine, you can spin up the Elasticsearch container and start using it right away. It's a simple and efficient way to get Elasticsearch up and running in no time. Okay, now that you've learned how to set up Elastic on your machine, let's jump to another part of the project. Before diving into how to integrate Elasticsearch into our .NET Core project, let me address something important. In older version of .NET, we commonly used two packages for Elasticsearch integration, Elasticsearch.net and Nest. However, both of these packages have been deprecated and are no longer actively maintained. If you are working on new projects, it's recommended to use the newer and actively supported package, elastic.clients.elasticsearch. We are going to use this package in our project today. There are multiple ways to install the elastic.clients.elasticsearch package, but I'll show you how to do it via Manage NuGet packages in Visual Studio. Right click on the project and select Manage NuGet packages. In the browser tab, search for elastic.clients.elasticsearch. Select the package and click install. That's it. The package will be added to your project and we are ready to start working with Elasticsearch in .NET Core. Okay, before we dive into coding, let me explain a bit about the structure of this project. This is built using the Killian architecture pattern, which helps us maintain a well-organized and scalable code base. If you are new in this channel or not familiar with Killian architecture, I highly recommend you watch my detailed tutorial on it. You'll find the link to the video in the top right corner of your screen. It will give you a solid understanding of how this structure works and why we are using it in this project. Now that we've covered the basics, let's move on and start implementing Elasticsearch in our project. Alright, now that we've set up the Elastic package, let's register the necessary services for our project. Open program.cs. Here you will configure the Elasticsearch client settings and register the required services. In this setup, I created an instance of Elasticsearch client settings using the URL, username, and password from appsettings.json file. Additionally, I bypassed SSL certificate validation for development purposes. I registered the Elasticsearch client as a singleton service and added the search product handler as a scoped service. I'll discuss the search product handler class in detail later. I also configured the Elasticsearch settings in the appsetting.json file. These settings include the default URL and port for connecting to Elasticsearch, and by default the username is set to Elastic. To obtain the password for your Elasticsearch instance running in Docker, you can use the Elasticsearch-reset-password tool. Open your terminal and run the following command to access your Elasticsearch container. Replace this part with the actual name of your container. Once inside the container, execute the following command to reset the password for the Elastic user. This command will prompt you to set a new password for the Elastic user. After resetting the password, update the password field in your appsettings.json file with the new password. Okay, now that we've configured these settings, let's talk about one of the most important parts of Elasticsearch in our application. Here in our controller, we have search products method. This method is exposed as a get endpoint at API product search. It accepts a query parameter named termed, which represents the search term input by the user. The method accepts the search term via the from query attribute, allowing users to pass the term as a query parameter in the request URL. The method invokes product service.indexProducts async, passing the search term to initiate the search process. This method is responsible for ensuring that searches are quick and efficient, while also keeping Elasticsearch updated with the latest data. Let's go step by step through what this method does and how it integrates with the search products handler class. The method begins by calling the search products async method from the search products handler class. This checks Elasticsearch for any matching records with the given search term. Elasticsearch is highly optimized for searches, so this is the first and most efficient step. Let's now break down the search products async method in search products handler class. This method queries the products index in Elasticsearch for the search term using a multi-match query. It looks specifically at the product name field to find matches. If the query doesn't return a valid response, the method returns an empty list. Otherwise, it converts the matching documents into a list and returns them. If the Elasticsearch doesn't yield any results, the method falls back to the SQL Server database. It retrieves all products from the database using the product repository. This ensures we still deliver accurate results even if Elasticsearch hasn't been updated yet. After retrieving the data from SQL Server, the method ensures it gets indexed into Elasticsearch. This is done with a bulk request. The bulk index operation is used to create a collection of indexing operations for all the retrieved products. Finally, the Elastic Client.bulk async method sends this bulk request to Elasticsearch. This step updates Elasticsearch so that subsequent searches are faster and don't require hitting the SQL Server. This process ensures a seamless integration between Elasticsearch and SQL Server, optimizing for both STIP and data consistency. It's a great example of combining search performance with robust data fallback mechanism. Okay, now let's walk through testing our search products API endpoint using Postman while exploring how it interacts with both SQL Server and Elasticsearch and how we can enhance the search functionality. Our application uses the Northwind database and products table is of particular interest in our case. The products table contains details about each product, including its name and a foreign key reference to the categories table, which holds the category names. Before testing, ensures that your application's SQL Server and Elasticsearch services are up and running. In your development environment, set breakpoints in the search products index products async and search products async methods to monitor their execution. First, I open Postman and create a new GET request. This URL targets our API endpoint with Chef as the search term. When I send this request for the first time, the application will attempt to find the term chef in Elasticsearch. Since Elasticsearch is initially empty, it won't return any results. As a result, the application queries the SQL Server database for products matching the term. The retrieved products are then indexed into Elasticsearch using a bulk operation, ensuring that future searches can be served directly from Elasticsearch. And now you are seeing the results from SQL Server in Postman. For the second request, when I send the same search term, the application will now find the term chef in Elasticsearch. As the data was indexed during the first request, this time Elasticsearch retrieves the matching products directly, bypassing SQL Server, which results in a faster response. In Postman, now you are seeing the products retrieved from Elasticsearch. Let's keep going. Now try searching for the term Alice by making another GET request to this URL. This time the search term is Alice, and you'll notice that Elasticsearch can still retrieve data without needing to query SQL Server. Since the data was already indexed from previous requests, Elasticsearch will handle the search this time, and you'll get the result from Elasticsearch instantly. No SQL Server query needed. Pretty awesome. By following this process, you've now tested the search products endpoint, seen the initial data retrieval from SQL Server, watched how Elasticsearch gets populated during indexing, and confirmed that subsequent searches use Elasticsearch for fast responses. But there is more. If we want to make our search even more powerful, we can add the category name field to the search. Right now, we are searching just by product name, but by adding category name to the mix, we can give users the ability to search for products based on both their name and their category. However, here's something important. Both the SQL Server side and the Elasticsearch side need access to the category name field. In SQL Server, that's already part of the products table, and in Elasticsearch, we just need to make sure that the field is indexed properly. Once both sides have access to this field, we can modify our search products async method to search across product name and category name fields. Then users can search for products like Chef or Alice from both product names and categories, getting even more accurate and meaningful results. And once you've learned all these features and worked with them, it's your job to take it a step further. You can now add category name to your queries and test your application with this new functionality. If you are able to implement this successfully, it's a clear sign that you've understood the tutorial and are ready to move on to more advanced concepts. You've mastered this level, and now you are prepared to go to the next level in your learning journey. And that's a wrap for today's tutorial. We've explored how to use Elasticsearch to implement full text indexing for fast and more efficient search capabilities. By leveraging Elasticsearch, you can scale your search functionality to handle large amounts of data while delivering real-time search results to your users. It's an incredibly powerful tool, especially when combined with your existing database like SQL Server to provide a seamless search experience. I hope you found this tutorial helpful and are excited to start using Elasticsearch in your own projects. Thanks for watching, and if you enjoyed this video, be sure to like, subscribe and hit the bell icon for more tutorials. Keep coding, and I'll see you in the next one. Cheers.